What do the movies Armageddon and Deep Impact have in common? That's right. They're both movies that tell the harrowing stories of what would happen if a huge rock from space collided with Earth. The effects are pretty scary, and you would probably think that any impact from a large space rock could spell the end of the world. Thankfully, those movies are fictional. While impacts like those haven't happened in modern times yet, it's still possible for a huge celestial object to hit Earth. We may not even know it, but there have actually been a good number of close flybys of what astronomers call near-Earth objects, or NEOs. In today's video, we'll be talking about comets that came dangerously close to Earth. But before that, let's take a look at the differences between the space rocks that NASA is constantly watching. What are comets and how are they different from other giant space rocks? There are a number of different objects that can come close to our planet's orbit. These include comets, asteroids, meteoroids, and meteorites. Comets are celestial bodies composed of ice, gas, and dust. They orbit the sun, and when they get close to the sun, some of the icy material vaporizes, producing a distinct tail. The tail always faces away from the sun. Asteroids, on the other hand, are made entirely of rock. There are metals present in many asteroids as well. They also orbit the sun, but because they don't have any ice, no tails form. Meteoroids are small parts that break off from asteroids or comets. Some of them reach Earth, but they're small enough to completely burn up while entering the atmosphere. But if it does manage to land on the surface of the Earth, it's then called a meteorite. Most meteorites land in the ocean, causing no damage or human casualties. Now, let's go back to comets. How big are comets? Comets are much smaller than planets. They're usually less than 20 kilometers across, which is about the size of a small city. But because they travel fast, they possess enough energy to do significant damage if ever they would hit Earth. Also, because of their size, comets can be influenced by the gravitational fields of nearby planets. So if a comet normally has an orbit that is far away from Earth, external gravitational forces can nudge it closer and closer to Earth's orbit. What would happen if a comet crashed on Earth? If the comet is relatively small, less than 100 meters in diameter, it would completely burn up in the atmosphere before it hits the surface. Objects like that are completely harmless. On the other hand, if a comet were 10 kilometers across or larger, the impact would be catastrophic. David Morrison, a NASA scientist, likens it to the mass extinction event that wiped out the dinosaurs 65 million years ago. Cities near the impact point would be leveled instantly, and places farther away would still suffer extensive damage. An impact of a comet that big would be like setting off millions of nuclear warheads simultaneously. And that's just the immediate effect of the impact. Afterwards, the entire world will be enveloped by a giant firestorm of comet debris, which would burn forests, buildings, and anything in its path. Then, the planet will plunge into total darkness for several months because of all the dust launched into the atmosphere by the impact. This phenomenon is known as an impact winter, and it's completely bad news for plant life. With the sun blocked out, plants have no energy source for photosynthesis, and they would eventually die. Animals which depend on plants for food will then have no source of food, and they soon would die as well. This will then have a chain reaction of extinction that would later extend toward all species. Here's the kicker. A comet doesn't have to be 10 kilometers across to cause that kind of destruction. According to astrophysicist Garrett Verschuur of Rhodes College in Memphis, Tennessee, based on computer simulations, a comet with a diameter of 1 kilometer is enough to cause the end of civilization, and something more than 5 kilometers across may spell the end of Homo sapiens themselves. Thankfully, after the object that caused the mass extinction at the end of the Cretaceous period, there hasn't yet been a similarly sized rock that crashed into Earth, but some comets did come close to home. Comets that came close to Earth. Before we name the comets that actually came very close to the planet, it's important to recognize one thing. When dealing with comets and other celestial bodies, distance measurements can be mind-boggling. We're talking millions, billions, even trillions of kilometers away. To simplify the numbers, astronomers use a different unit of measure called the astronomical unit. This is defined as the mean distance between Earth and the Sun, which is about 150 million kilometers. So a comet that's 2 AU away from Earth is 300 million kilometers away, or twice the distance between the Sun and the Earth. Now back to our near-Earth comets. One of them is the famous Halley's Comet, which had not one but 3 close calls with Earth at different points in time. The closest pass happened in 837 AD when Halley's Comet came within 0.03 AU of our home planet. Centuries before, in 607 AD and in 374 AD, Halley's Comet also brushed past Earth at as little less than 0.09 AU each time. Halley's Comet is 15 kilometers across, so it can trigger an extinction-level event if it were to collide with Earth. Another comet that almost grazed the Earth more than once is called 73P Schwarzmann-Wachmann. This comet came near the planet twice, once in 1930 at a distance of 0.06 AU and again in 2006 at about 0.08 AU. 73P Schwarzmann-Wachmann has since broken up into more than 30 different fragments as it orbits the Sun, and some of these fragments would occasionally show up in the giant telescopes used by astronomers in observatories. By far the closest approach of a comet to Earth was 0.015 AU. This happened in 1770 with an object known as Lexell's Comet. This only happened once, though, because 9 years later, the comet was thrown off by Jupiter's gravity when the comet passed near the planet. Since then, Lexell's Comet is no longer classified as a near-Earth object. In other words, it won't come dangerously close to our home planet anytime soon. If you've seen the Leonid meteor shower, here's some nice trivia. A comet is responsible for those shooting stars that often show up every November. That comet is called 55P Tempel-Tuttle, and it came within 0.02 AU of Earth during its approach in 1366. The rocks that make up the Leonid meteor shower are materials from the comet's tail left behind in space. The parts that intersect with Earth's orbit are responsible for the beautiful display of shooting stars every year. But the meteor shower is usually faint and doesn't last long. But once every 33 years, the Leonid meteor shower intensifies into a meteor storm. When this happens, more than 1,000 meteoroids fall from the sky at once, creating a more spectacular light show. The last Leonid meteor storm happened in 2002, so we can expect another one in 2035. Another majestic shooting star event that happens once every year is the Perseid meteor shower. It often occurs in August, and it's caused by debris left behind by the comet 109P Swift-Tuttle. It passes close to Earth every 130 years. After its flyby in 1992, astronomer Brian Marsden from the Harvard-Smithsonian Center for Astrophysics made a prediction that the comet may impact Earth in 2126. 109P Swift-Tuttle is an enormous object measuring 26 kilometers across, and it blazes through space at an astounding 58 kilometers per second. If the comet were a plane, it would be flying at Mach 150, or 150 times faster than the speed of sound. If this comet were to hit Earth head-on, the impact would produce 300 times more energy than the collision that killed off all the dinosaurs 65 million years ago. That would spell the ultimate disaster for us and our planet. Thankfully, 109P Swift-Tuttle would not likely crash on our planet sooner or later. Brian Marsden's prediction was retracted later, and NASA scientist Donald Yeomans confirms this. Based on data from the comet's 1992 flyby and previous data from sightings in 1862 and 1737, Yeomans and other astronomers were able to recalculate the comet's path. They later concluded that an impact in 2126 is highly unlikely.